Ever wondered how your body responds to exercise? Welcome to the fascinating world of exercise physiology, the study of how the body adapts to physical activity and exercise. Now, you might be asking, what are the primary energy systems used during exercise? Well, your body relies on two main systems: the aerobic, which is oxygen dependent, and the anaerobic, which is non-oxygen dependent and includes the phosphagen and glycolytic systems. Speaking of oxygen, you've probably heard of VO2 max, but what exactly is it? Simply put, it's the maximum amount of oxygen a person can utilize during intense exercise. It's a key measure of your aerobic fitness. But how does exercise impact cardiovascular health? Regular exercise is like a tonic for your heart. It strengthens the heart, improves blood circulation, and reduces the risk of cardiovascular diseases. Ever felt your muscles burning during a tough workout? That's probably because you've hit your lactate threshold, the point at which lactic acid accumulates in the muscles faster than it can be cleared, leading to fatigue. And what about when you're sweating buckets? That's your body regulating temperature through processes like sweating, vasodilation, and increased respiration. After a hard workout, your body goes into EPOC, or excess post-exercise oxygen consumption, an elevated state of oxygen consumption that represents the energy required to restore your body to its pre-exercise state. Resistance training buffs, listen up. This type of training stimulates muscle hypertrophy or growth, and increases strength by causing microtears in muscle fibers that repair and adapt. Now let's talk about the powerhouses of your cells, the mitochondria. They're responsible for energy production, and exercise can increase their number and efficiency, enhancing your aerobic capacity. Exercise is also a boon for your bones. Weight-bearing exercises stimulate bone density and help prevent osteoporosis by promoting bone remodeling. Ever use the RPE scale during a workout? The rating of perceived exertion is a subjective measure of exercise intensity based on your perception of effort. Aerobic exercise is a key player in fat loss, increasing calorie expenditure and creating a caloric deficit. And what about glycogen? Stored in your muscles and liver, it's a primary source of energy during high-intensity exercise. The principle of specificity in exercise training states that training adaptations are specific to the type of exercise or activity performed. So, if you want to get better at something, do that thing. Exercise also has a positive influence on insulin sensitivity, reducing the risk of type 2 diabetes by enhancing glucose uptake. If you've ever felt sore a day or two after a workout, you've experienced DOMS, or delayed onset muscle soreness. This is due to microscopic muscle damage. Finally, altitude training can enhance your aerobic performance by stimulating adaptations such as increased red blood cell production. So, there you have it, a whirlwind tour of exercise physiology. Remember, every time you exercise, you're not just burning calories. You're engaging with a complex and fascinating physiological process. Until next time, stay curious and keep moving.